Hi, Chem 30s. I hope you're ready. This is going to be a relatively lengthy lesson here on our very first topic for organic chemistry, so concept C2. We already covered C1 earlier. Remember that just had us looking at where organic compounds come from and what defines an organic compound, and we said that it's a compound composed of carbon and other atoms, but it is not an oxide of carbon, nor is it, or nor does it contain an ion that contains carbon. So what we're going to get into today, I'm hoping, is we'll get through discussing what alkanes are, and then getting a little bit deeper into how we can draw and name simple organic compounds. I've said this to you before, but this becomes a very fundamental part of this unit, and you're going to need to be able to really really understand this in order to keep moving forward in this unit. So, naming alkanes. Alkanes are the simplest kind of organic compound out there. They are a hydrocarbon, which means that they are composed of solely carbon and hydrogen. And central to understanding how they work is understanding carbon. And carbon is at the middle of everything there. We know from Chem 20 that carbon is able to make 4 bonds. And without this property, we would not have the millions of organic molecules that exist in our world. Carbon can make long chains and even rings, and we'll get to those rings in concept C3. Naming of organic compounds is the third naming system that we've developed so far. We've already learned how to name inorganic substances like ionic compounds and molecular compounds, but we're going to learn another one, which is going to be learning the beginnings of organic compounds. Organic names, and this is important, they're going to have prefixes, which are beginnings, roots, which are middles, and suffixes, which are ends. And pretty much every organic compound is going to have a combination of those. The main part of an organic molecule's name describes how many carbon atoms there are in a straight line chain. In other words, the longest chain of carbons in a row names the molecule. So, for example, and we'll get to this in a second, if I have 2 carbons in a row, okay, with a bond between them, I'm not drawing anything else with them, that's the longest chain in a row, so that would give us a particular name. If we were to add another carbon onto that, that changes the name. The other thing that's interesting about this is if we have, let's say, a branch coming off of this hydrocarbon, let's say there's one right there, we use the size of the branch, the number of carbons in the branch, to describe that branch, what we call an alkyl group. So this is a 3-carbon chain with a 1-carbon branch. I hope you guys can see that. This table is something that you need to memorize. Okay, so I would make a note of this somewhere, and I would go home tonight and I would start to memorize this. Okay, because you don't get anything on the diploma exam or on any of my tests that are going to tell you what's going on in this particular diagram. So the number of carbons in the longest chain is in this column here. The stem name or base of the compound is here. The alkyl group name is very similar. You'll notice that it's very similar here. And then the multiplier, which we've learned these already, is described here. So if we had a 1-carbon compound, it would be a meth something, methane, for example. If we had a 1-carbon branch, it would be a methyl branch. Remember the alkyl groups, these are the branches coming off of the compound. Okay, and these are the actual roots or stems of it. 2-carbon stem is an eth something, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. Okay. Over here in the branch names, these are the same. Honestly, we're probably not going to go much past here because the compounds get a little too complicated at that point. So a branch with 1 carbon in it is a methyl branch. A branch with 2 carbons in it is an ethyl branch. Branch with 3 carbons, propyl, and so on. So notice how prop, eth, meth, meth. So you just have to remember branches have the YL, and the stem is no YL. It's just meth, eth, prop, bute, etc. The multiplier column here is dealing with when we have more than one of the same entity on the compound. So for example, if we had 2 1-carbon branches, that would be dimethyl. If we had 3 1-carbon branches, that would be trimethyl. I hope that makes sense. So, like I said, you need to make sure you spend some time memorizing this tonight, because you're not going to have it on your first quiz. You're not going to be given a chance to go back and refer to it at any point. Okay, so make sure you get meth, eth, prop, bute, pent, hex, hept, oct, non, dec memorized. Make sure that you have these ones memorized as well. Okay, so you should recognize some of the roots that we just described from earlier works that you guys have had from earlier courses that we've done. So for example, how many carbons would you expect octane to have? And octane is part of gasoline, and you would expect it to have 8 carbons. How many carbons are in a butyl group? A butyl group will have 4. And how many methyl groups are in tetramethyl lead? Tetra, again, is 4. So all of these little prefixes that we add on to things are going to become very important. Make sure you spend the time to get them memorized. Using just the prefixes and roots, you can figure out what dimethyl propane is made of. Okay, break it down. Okay, so here is our root, prop. Prop means 3. We'll explain what ane means in a second. So prop tells us that there is a carbon chain which is 3 carbons long. And the dimethyl, di refers to 2, methyl refers to 1 carbon branches. So dimethyl refers to the number of methyl groups, which is 2 groups, and each methyl group has 1 carbon atom. Okay, so this name, dimethylpropane, is pretty logical the way it's broken up. Check for the suffix here, which describes the types of bonds between the carbon atoms. If it's A-N-E, that means that they are only single bonds between the carbon atoms. Okay, whereas, and we'll get into this later, E-N-E at the end is going to be double bonds. Okay, this is horrible for writing. And then Y-N-E is going to be triple bonds. Okay, so propane means prop is 3, ane means single bonds. Dimethyl refers to the number of methyl groups. So di meaning 2, methyl meaning 1 carbon atoms. When we get to actually drawing these compounds, I tend to work from the back towards the front. So I'll have a look at this first, prop, 3 carbons in a row, ane, single bonds between the carbons, and then I'm going to start to build off of that. I'm going to have 2 methyls that are going to build off of that. And we're going to play around with that in a minute here. But for now, let's just keep things relatively simple. for now, let's only look at straight chain molecules with a carbon. Straight chain meaning there's no branches coming off of it with other carbons. And we're going to look at straight chain molecules with carbon and hydrogen held together with single bonds. So, for example, this is a beautiful molecule right here. In order to figure out what this molecule is, we're going to take just a little bit of time to try to break it down a little bit. First thing is that each carbon, and you have to remember this, each carbon bonds 4 and 4 times only. Okay, not 5, not 3, but 4. So if you look at this particular carbon here, it has 1, 2, 3, 4 single bonds. 3 of those single bonds are attached to hydrogen. 1 of those single bonds is attached to the next carbon in the chain. This carbon is bonded 4 times. 1, 2, 3, 4. 2 of those bonds are attached to hydrogen. 2 of those bonds are attached to carbon, and so on. So this is a 5 carbon molecule. 1, 2, 3, 4, 5. We know that 5 means pent, which you can see down here. And because each of the bonds between the carbons is a single bond, okay, remember a double bond would look like this, but we don't have a double bond in this case. So each of these is a single bond. Okay, that means that we're going to use the suffix ane. So pent refers to the 5 carbon atoms, 1, 2, 3, 4, 5, and the ane suffix tells you that there are only carbon and hydrogen atoms and only single bonds. So pentane can also be written in a chemical formula form as C5H12, and if you don't believe me, take a second to count. So what I'm going to get you guys to do in a second here is draw out the first 10 of these just to get practice at drawing again. Okay, so the first 10 alkanes, ane, remember, referring to single bonds made of carbon and hydrogen, are methane, ethane, propane, butane, hexane, heptane, octane, nonane, and decane. Alkanes do go beyond 10 carbons in a row, but we don't in this class. It's not required for us to learn it, so why don't we keep it relatively simple? I mean, for example, we could have to memorize that candle wax or paraffin is C25H52, but that's really not going to help you out all that much. So what I'd like you to do is I've left you some space in your notes, and I'd like you to go through and sketch the first 10 alkanes. You can omit pentane because we've already done it, and I'd like you to write the names beneath each of them. Okay, so for example, I'll give you another one here. We're going to do methane. So methane is 1 carbon, and we know that each carbon has to bond 4 times. So if it's only 1 carbon, that means that what's surrounding methane are 4 hydrogens. So just go ahead and draw compounds like this. Underneath it, I'd like you to write their what I call molecular name or their simple chemical formula. So CH4 in the case of methane. Don't use X and Y, substitute numbers in. We're not going to put a 1 there. Okay, so take a couple of minutes to do that. Maybe 5 minutes to get those sketched out in your notes. Find some space for that, and then you can hit play again. So hit pause now, get that sketched, and then hit play when you're ready to go. Okay, hopefully that worked out for you. Now we're going to start to work with some branches. So those simple straight chain alkanes are pretty easy to handle. The practice is in memorizing the prefixes meth, eth, prop, but, etc. What we're going to do now is we're going to add a twist to this, and we're going to add some alkyl groups, or what we call branches. And remember that those branches have the same numbering system. So a 1 carbon branch is meth, a 2 carbon branch is eth, but instead we don't just say eth, we say methyl, ethyl, propyl, etc. So here's how we do this, and this really start to use this as a guide until you get comfortable with this. The very first thing you need to do is when you get a more complicated compound is you identify the longest continuous chain of carbon atoms, what we call the parent chain. And I am going to use that term exclusively now, the parent chain. Maybe not the root anymore, but we'll call it the parent chain. So you're going to go through and have a look at that structure that you have in front of you, and you're going to want to count along and find the longest continuous chain of carbon atoms in a row. And then we're going to number the carbon atoms from the end closest to the branches so that the numbers are lowest possible. And I'll explain what that means in a second here with an example. We're going to identify any branches and their location number on the parent chain, and then we're going to write the IUPAC name using the following format. The number of location, so let's say for example if it's coming off of carbon 2, then we'd write a 2 and then a hyphen, and then the branch name, so it might be methyl. Okay, there's our branch, so methyl meaning a 1 carbon branch, and then our parent chain, let's say it's attached to butane. So it would be 2-methyl butane. That's what it would look like if we wrote our name out like that. When writing the names of the alkanes, list the branches in alphabetical order. So for example, if we had another branch, and let's say it was an ethyl or 2-carbon branch, then it would be an ethyl methyl butane in alphabetical order. E comes before M, so it's ethyl methyl butane. The parent chain always comes last. Okay, no space between here, even though it looks like there is one. They just kind of go together. So 2-methyl butane, not 2-methyl butane. No space there. Okay, and we ignore prefixes in this case. So we're going to do an example here. This is a diagram representing a compound that you might encounter. And in this case, what we have to do, step 1 was to find the longest chain of carbons in a row. So 1, 2, 3, there's 4 carbons in a row. But watch out. This is a chain, right? 1, 2, 3. Okay. This is a chain. 1, 2, 3, 4. So far, 4 seems to be the longest. What we need to do next then, we know that we have 4 in a row. So that means that we have a bute. Okay. And then the bonds between each of the carbons are single bonds, correct? And so that means that we have a butane. Oh, that was a horrible A. Butane. Okay. Then the last thing we do is we identify that there's actually a branch right there. So this is carbon 1, carbon 2, carbon 3, carbon 4. Okay. And there's a branch coming off of carbon 2. It's a branch because it's another carbon up here. This is not a branch because it's just a hydrogen. Nor is this, nor is this. Okay, so carbon 1, carbon 2, carbon 3, carbon 4, branch coming off of the carbon. So we've identified there's a branch coming off of carbon 2. Okay, what kind of branch is it? There's only 1 carbon on that branch. So it is a 2-methyl, because it's a 1 carbon, butane. So this is 2-methyl butane. It's carbon 2 because the branch comes off of carbon 2. If, and this is not right, so don't write it down, but just pay attention. If you had decided to number it backwards, so 1, 2, 3, 4, you could call this, you might think to call this 3-methyl butane. But the problem is if you numbered it from left to right, you could reduce that number to 2 instead of 3. So these don't work, okay, because we're not getting the branches as low a number as possible. Okay, so that is 2-methyl butane. Now, that's how we name things. I'm going to go do some more examples in a minute here. But how do we draw these things? It's basically the same. If we're given the name, like I told you before, start by drawing the parent chain out first. So you're going to identify the parent chain in the name that you're given and write the number of carbon atoms from left to right. Then you're going to attach the branches based on what the rest of the name of the compound tells you to do, and then add hydrogen atoms to make sure that each carbon has 4 bonds attached to it. Okay, so let's do this one together. This looks complicated, Okay, but we'll break it down to make it really easy. So this is 3-ethyl 2,4-dimethyl pentane. Now technically there's a mistake here. This should be written as 2,4-dimethyl 3-ethyl pentane because D comes before E, but we're going to ignore that for now. We're going to start here at the end. This is our parent chain right here, pentane. So that means we have 1, 2, 3, 4, 5 carbons in a row. And it's an ane, meaning that they all have single bonds between each of the carbons. Now, we're going to number this 1, 2, 3, 4, 5 from left to right, like it said in the previous slide. And then we have to add our branches to it. So 2,4-dimethyl. 2, 4 is identifying that we have a methyl coming off of carbon 2. So I'm going to abbreviate that as CH3. We have a methyl coming off of carbon 4, CH3. And we have an ethyl coming off of carbon 3. So that's going to be CH2CH3. Okay. I hope that kind of made sense to you. So we start with the parent chain, then we start adding our branches. Okay, and so we've got a 3-ethyl, so there's carbon 3 with an ethyl coming off of it. Dimethyl with a methyl branch coming off of carbon 2 and carbon 4, carbon 2 and carbon 4, and then pentane. Okay, the last thing we have to do is we have to make sure that each carbon has enough bonds on it. So this carbon here is only bonded once, so we're going to need to add 3 hydrogens to it, so CH3. You could also have written that, just if you want to, it just takes a lot more time. You could do it this way. This is the same as doing CH3. Okay, I just prefer this because it's a little bit faster. The middle carbon here, 1, 2, 3 bonds already on it, so we're going to need another hydrogen. This carbon here, 1, 2, 3 bonds on it, going to need another hydrogen. This carbon here has 2 bonds on it, so we're going to need 2 hydrogens. And this carbon here has 1 bond, so it's going to need 3 hydrogens. Okay, so that is a very poorly drawn example of 3-ethyl 2,4-dimethyl pentane, which should technically be called 2,4-dimethyl 3-ethyl pentane, but don't get confused on that just yet. Okay, and that's what it would actually look like. Okay, so before we get on to talking about cycloalkanes, I'm just going to swing in a diagram here, and we're going to see if we can figure out what this compound actually is. And we'll do this, very simply if we can. It's going to have in here 1, 2, 3, 4, 5 carbons in a row, but let's just double check. 1, 2, 3, 4. 1, 2, 3, yeah, 1, 2, 3, sorry, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. So what we have is a 5-carbon chain. Okay, I'm not going to be able to write on this, unfortunately, for you. So 1, 2, 3, 4, 5 carbons in a row. So that makes it a pentane. Okay, we would number these from left to right, because it doesn't make a difference if we number them right to left or left to right. The branch still comes off of the middle. So this would be 1, 2, 3, 4, 5. We have a branch coming off of carbon 3, right, off of the 3rd carbon. Here is our branch. So this is a pentane with a single methyl branch coming off of carbon 3. So we would call this 3-methyl pentane. 3-methyl pentane. Okay, so that's one example. I'm going to go track down another one for you. Okay, and then let's just have a really quick. So let's see if we can come up with a drawing for this compound. 2,3-dimethyl Sorry, I'm just having trouble getting this working. 2,3-dimethylhexane is what we're looking at drawing here. So let's start with the parent chain. That's always going to be at the end. So it's an ane, meaning that single bonds. Hex is 6 carbons in a row. So 1, 2, 3, 4, 5, 6 with single bonds in between. Okay, and then we have a 2,3-dimethyl. So methyl meaning 1 carbon branches, dimethyl meaning there are 2 of them, 2, 3 referring to where on the chain, parent chain, those are located. So if we start here at number 1, 2, 3, 4, 5, and 6, then 2,3-dimethyl means that we have a methyl branch coming off here and a methyl branch coming off here. Okay, so 2,3-dimethylhexane, 2, 3. So that means there's 1 coming off of 2, 1 coming off of 3. Dimethyl meaning that there are 2 of them. Methyl meaning it's a single carbon branch. Okay, hexane meaning 6 carbons in a row for our chain. Last thing we need to do is make sure we've got enough carbons around, or enough hydrogens around every carbon. So this one only has 1 bond, so I need 3 more bonds. This one already has 3 bonds, so I just need 1 more. This one already has 3, so I just need 1 more. Normally I would draw these a little nicer with the H's actually beside, but it's really hard on the computer. 2 already around this one, so I'm going to need an H2 there to add 2 more bonds. 2 around this one, so I'm going to need an H2 there, and only 1 bond already around this one, so I'm going to need a CH3 there to make sure that works. So that's just a couple of examples before we get on to the cyclo versions of all of these. And boom, we're back to the cyclo version of all of these. That was probably crazy the way that jumped around, but sorry about that. So the last thing I think I mentioned to you earlier is that there are ways that we can draw these carbons in rings. Meaning that they're in geometric shapes, depending on the number of carbons in that ring. So not all alkanes are simple straight chains with little wee branches, or straight chains with little wee branches. Some alkanes actually form into rings we call cycloalkanes. The cyclo part actually refers to the ring that we're talking about. Remember, we only have single bonds to deal with, so a cycloalkane will have only single bonds. Alkane, A-N-E at the end, means single bonds between the carbons. And so we'll see some rings with double bonds later on. To name a cycloalkane, we would simply put the prefix cyclo in front of the parent chain name. For example, if it's a butane, we would do cyclobutane or cyclohexane. If branches are present, we'll treat the cycloalkane as a parent chain, starting your numbering in such a way as to keep your branch numbers as low as possible, just like we've done before. If there's only 1 branch in the chain, we don't need a 1. Okay, if there's only 1 branch, we can just call it, for example, methyl cyclobutane, if there's only 1 methyl group on that. So let's have a look at this. Draw the structural diagram for 1-methyl 2-ethyl cyclopentane. Again, I screwed up on this. E comes before M, so it should be 2-ethyl 1-methyl cyclopentane. But let's start. Cyclopentane. What that means is we have 5 carbons, but they're going to be arranged in a geometric form with 5 points on it, which, if you're keeping score, is a pentagon. Very poorly drawn pentagon. Now at this point, once you've drawn your cyclopentane, we need to add our branches. You can decide which carbon you want to be number 1. There's really no rhyme or reason. So if we call this number 1, we'll go clockwise around because that's the way we tend to work things. So 1, 2, 3, 4, 5. And then we have a methyl branch coming off of carbon 1. So we'll put a CH3. And then we have an ethyl branch coming off of carbon 2. So that's going to be CH2, CH3. Okay, so this is a 1-methyl 2-ethyl cyclopentane. Hope that makes sense. Okay, I'm switching to the next one. So what is the IUPAC name for this cycloalkane? So the first thing we need to do is we need to go through, I'm going to change the color of my pen here real quick, just so that you guys can see it. We're going to go through and we're going to start counting. Okay, at this point, it doesn't matter where you start counting, just as long as you remember, hey, we started there. So 1, 2, 3, 4, 5, 6, 7, 8. So what we have is a cyclooctane. So cyclooctane. Don't need two O's in there. It's not cyclooctane, it's cyclooctane. Okay. And then we have to figure out branches, but what's really important is to get the numbering as low as possible. So you might consider this one being 1, 2, 3, 4, 5, 6, 7. Okay, but then that gives us a 1, 3, 7 for our branches. But I'm just going to show you. I'm going to erase these and we'll start again. Oops, didn't want highlighter. I'm going to start again by erasing those things. And I'm going to show you that, in fact, we can get the number lower if we try. So what if we started numbering here and went 1, 2, 3, 4, then 5. Sorry, I jumped ahead. That's a 4. Let's erase that and make that just a little bit nicer. So erase. Okay, you guys like the sound effects, I hope. Probably rolling your eyes right now, but that's okay. So that's a 4. So remember, we had a 1, 3, 7 before. Right now, for our branches, we have 1, 3, 5, which is a much better place. Lower. That last number is lower. So this is the numbering that we're going to stick with here. So we've got a cyclooctane. Each of the branches, this one, and that one, are all single carbon branches. So those are methyl branches. So we could put in here methyl. So it's a methyl cyclooctane, but there's 3 single carbon branches. So that means that it's trimethyl cyclooctane. And then what we have to do is we have to identify where those branches are coming off of. So we have one coming off of carbon 1, one coming off of carbon 3, and one coming off of carbon 5. So it's 1, 3, 5 trimethyl cyclooctane. That's a mouthful. But I hope you guys see, where did I start? I started with my parent chain. I saw it was a cyclo, so I put that there. Then I built backwards. I looked at my branches. I found out how many of them there were. They were all the same. And then I identified what numbers they were. It's the same procedure that we're going to do. That procedure, starting with the parent chain, working our way back to the front of the molecule, that is what we will do continuously from now until we're done this unit. So that's why I said this is a foundational part of the unit, is that we're going to keep doing that the same way every time. We did it back here on this slide too. We started with the parent chain, worked our way back to the front of the molecule. Same kind of thing that we did here. Okay, so I think that was probably close to 40-45 minutes of me talking. So what I'm going to do now is pause. So I'm going to pause where we started or where we ended here and say that that's probably enough for us to cover in one day. And I'm going to give you guys a little bit of practice at this point. So your sub has a worksheet that looks something like this. And I'm going to get you to get started on it, but you can't do everything on here. And it's going to look similar to this, but not entirely like this, because let me see if I can pull up a different one. I'm just going to pause. Okay, sorry for making that so choppy. This is the one I want to show you. So this is the one that your sub has for you. And what I'm going to get you to do is work your way through the ones that you can work through on this worksheet. So your sub will hand them out for you in a minute. All I'm asking you to do is, if I give you the IUPAC name, I want you in this box to draw the structure. Something like this, but obviously to represent this. If I give you the drawing, I want you to write the name over here. And you should be able to do question 1, 2, 3, 4, 5, 6, 7, 8, and then we're going to stop there. So go and do questions 1 through 8 on this worksheet. Okay, challenge yourself to do this. See if you can figure it out on your own. If you can't quite get it, that's fine. We'll chat tomorrow. Don't forget to work in pencil on this. Okay, if you make mistakes, it's easy to correct that way, and chances are you're going to make mistakes as we start here. Remember to always start off first with your parent chain and write that out, okay? And then work your way back through the molecule. Remembering these numbers refer to the number on the parent chain. The tri, in this case, tells me that we have 3 methyls. Where do I locate those methyls? I locate them on carbons 2, 3, and 4 in this octane that we're dealing with. Okay, same thing on these ones. Remember to go through and count your longest parent chain. So if you go 1, 2, 3, 4, that seems okay, but I was tricky on this one. Notice that we can go 1, 2, 3, 4, 5. I never doubled back over anything. 1, 2, 3, 4, 5. Oh, so this is a pentane of some sort with a branch on it. It's not a butane with an ethyl branch. It's a pentane with a methyl branch. Okay, so work your way through these, see how it goes. When I'm back tomorrow, we'll sit down and see how it went. Remember, this is foundational, so try your best to understand everything that's going on here. Mark questions you're not sure of, and when I'm back tomorrow, we can fiddle around with this a little bit more. If you get through questions 1 through 8, then go ahead and have a look at alkenes and alkynes, which is the next section in your notes, but I'm not going to have you have absolutely do that today. But have a look if you do get this done. It would be great if you had questions 1 through 8 done for tomorrow, and then we'll go through them either together, or you'll have the key to look at to figure out where you went wrong, if you went wrong. So I hope that was good for you. We'll see you tomorrow. Best of luck with all of this.